Today we're going to be analyzing average rate of change, what it is and what it looks like. For starters, we know we can analyze the graph that we are all familiar with, the graph of a line. The graph of a line is very simple to digest. We know that the line equation is ax plus by is equal to c. That's the general formula for any given line. And we know we can rewrite this for y is equal to negative ax, b times y is equal to negative ax plus c, y is equal to negative a over bx plus c over b. This is written of the same line in point slope formation. What this tells us is this line of y has a slope of negative a over b and a y-intercept of c over b, which is why this notation of a line is known as a slope-intercept function. So we know that for this line there's a slope, and particularly average rate of change is just the slope of a line. What do I mean by this is, well, let us analyze any given point within this line function. Let us take when x is equal to negative 2 right here, and let us take this point in green when x is equal to 4, and let's take this point when x is equal to positive 6. So we have these 3 points on the line. And what do we know about these points? Well, we know that the average rate of change between any of these two points will have an average rate of change in negative a over b. Why is that? It is the reason why for this is because that for every point on a line, the rate of change is always a constant. And to figure out the rate of change is simply the slope. So if we wanted to find the rate of change between point A and point B, to find this we simply find the slope of the line that passes through these 2 points. So the x coordinate of B, let's call that x of 0, comma y's of 0, and let's call point A's x coordinate to be x of 1, comma y's of 1. To find the slope of segment AB, or in other words, the average rate of change of the distance between points A and B, this will be equal to the slope, that is, the change in y0 minus y1, over the change in x, which is x0 minus x1. And to graph this visually, what this means is we take the change in y right here, and we take the change in x right here. So and this will be perpendicular, so this will be change in y represented by delta y, and this will be change in x represented by delta x. This concept of a slope and what the slope is and how to find the slope of a line is essential to understand average rate of change. So the average rate of change between the points A and B will be y0 minus y1, the y coordinates of point B and A respectively, and divided by x0 minus x1, the points of B and A respectively for the x coordinates. This will give us the average rate of change within this line segment. And we can do that for likewise if we wanted to find the average rate of change between points A and C. But we know that since point B and A lie within this graph, within y is equal to negative a over b, the plus c over b right here, the 2 points of A and B both are defined by this line function. So we know that the slope of this line will always be a constant of negative a over b. The slope of a line is constant. It doesn't change. So the average rate of change between points C and A will likewise also be equal to negative a over b. So what have we learned from this? We learned that to find the average rate of change between 2 points is simply finding the secant line that goes to the 2 points of the slope. So the line that passes through A and B will be the function of y is equal to negative a over bx plus c over b. That slope is negative a over b, so that is our average rate of change between points A and B. Likewise for points A and C, because the 2 points also lie on the graph of y is equal to negative a over b, x plus c over b. Moving on to a much more harder example. And for starters, let's draw our y and x intercepts. instead of having a line where the average rate of change between each and every single point on it will be the same, let us take the example of a parabola. And let's say this parabola is equal to y is equal to ax squared plus bx plus c. This is the general formula for any parabola. And since a parabola is a curve in a conic section, we know that for every point within this graph, so the point right here, the point right here, or the point on the left-hand side, they will all have different rates of change. And these rates of change will differ depending on what point and what region you're on. And since we're talking about average rate of change, let us apply that knowledge we learned from the line into our parabola. So the average rate of change, the average rate of change is equal to, or defined to be, the slope of the secant line that passes 2 points which you want to find the average rate of change for. The average rate of change can only exist between 2 points that you want to find. So for example, let us call this point point A, and let's call this point point B. I want to find the average rate of change of the interval between, which is supposed to be inclusive, so let me draw the brace, A to B. I want to find the average rate of change between these 2 points. And how do I find that? Well, we know that that's simply the slope of the secant line that passes through these 2 points, which, if I could draw better, will look something roughly like that. This secant line will have a slope. This secant line will also pass through the points A and B. It's not drawn well, but it should. This line that passes through these 2 points will be the average rate of change between the intervals of A and B. And why can the average rate of change only exist between 2 points? Because we can only find a line equation given 2 points. So if I have the point of x0 comma y0 and I have the point of x1 comma y1, how do I find the line equation that passes through these 2 points given that the line that passes through it will be the average rate of change? Well, this will be equal to x minus x0 divided by y minus y0 is equal to x0 minus x1 divided by y0 minus y1. This is the equation of a line given 2 points on it. So we can apply this knowledge for the average rate of change. For a conclusion and a review, the average rate of change is the slope of a secant line that passes through the 2 points of an interval that you wish to include. So if I have point C here, the average rate of change between C and A, average rate of change, if I change color to green, between C and A, inclusive, will be this line in green. The secant line that passes through these 2 points is slope. The slope of this green line will be the average rate of change between the points of C and A. So we have concluded our understanding of finding average rates of change within graphs. In the next video, we'll be analyzing instantaneous rate of change, which will tell us the slope of the tangent line that goes through one point, the instantaneous rate of change for that given point on a curve. I hope you have learned something new.